Hello, everyone. Welcome back to the Technically Developers Conference. My name is Julie Zeglin. I am Technically's managing editor based here in Philadelphia, and I'm your MC for the day. So I'll be introducing the rest of the case studies for the afternoon. I hope you've also gotten a chance to check out the exhibitor room. That's where all of our sponsors are hanging out. They're talking about positions they're hiring for, workplace culture, things like that. So give them a shout at some point between the sessions. But our next case study, let's get ready. So we have Adam Mohammed coming. He is going to be speaking about infrastructure differential diagnosis, how to be a server shaman. How can you empower your team to collaborate when solving infrastructure-related problems? Hear real-life case studies from cloud services company Linode, which is based in Old City, Philadelphia. Adam, can you join us?
Yep, thank you.
Yes.
All right, so let me pull up my things. All right, so hi, I'm Adam Mohammed. I'm going to be doing this talk, and this is something that once I started at Linode about a year and a half ago, just about a little bit over that, I was put on quite a few teams. So I started originally on just our login service team, where it was a Python Flask app, and moved over to helping build our Linode Kubernetes platform. And now, for the last 6 months, I've been on our storage platform. So I've seen quite a few different teams staffed in different ways, some with dedicated systems resources, some with dedicated ops resources, some with just DevOps, and some with just developers. So I've seen quite a few different ways of how people tackle their own problems. And I kind of wanted to summarize this and kind of show what I found is a methodology that works for teams. That you can kind of implement in a way that prevents silos. So let's get into it. So I thought I talk about diagnostic strategies for this. And so I kind of found that there are two ways that people go about diagnosing problems. And the first way is kind of the easiest way to go. I call it the shotgun method. It's just this unstructured way. You are heavily reliant on knowing your system. So this works well if you have a lot of experience in the system, but then the counterpoint to like having a lot of experience is that you end up with the guy or the girl who does that problem. So anytime that system breaks, you go to person X to go solve that problem, and you can obviously see problems with this, especially being this portion of the conference where this is supposed to be for growth. You don't really want to have one go-to person for every single thing. You want to be able to repeatedly diagnose problems, and you want it to be transferable. So the alternative to just kind of going off of existing knowledge and kind of your kind of shotgun approach is using a structured diagnostic strategy, something like the scientific method. I'll even go into the specific method that I end up using, but all this requires is knowledge of how to like read and interpret your metrics. And you don't need to know as in-depth detail about how your system is, architected. You can actually just kind of take that knowledge that you've been amassing over time, and then because you're using a structured way to go through everything, you can repeat it. And as such, because it's repeatable, you can kind of share your exact process with your teammates, and they can also solve your problems as well. So you don't end up with person X anymore. You end up with a team of people who can all diagnose problems. So I kind of have this is what differential diagnostics is. It's actually from the medical field. So differential diagnostic procedure is something that's comprised of 4 steps. So a patient comes in, and a physician's job when they're using this procedure is to gather all the information about the patient, any symptoms. So they're asking things about like what are the things that you're feeling? Do you have any history? And you've all been to the doctor. You've probably have gone through this, and it sounds like for them it's so routine. It's just a checklist that they're running through in their head. And so they're hearing all your symptoms, they're hearing your family history, and then in their mind or maybe even on paper, they're listing out possible causes for these symptoms, and then prioritizing those causes based on severity. So if there's something that may need, emergency surgery, that's going to be at the top of the list. So they'll ask you things based on those symptoms first. And so what a differential diagnostic is going through that list of possible diagnoses and asking questions to rule them out. And this is a kind of a normal practice in the medical field. And so my kind of toy example here is, let's say I am a patient and I'm going to the doctor because I have a cough and some chest pain. So I told my doctor this, and he said, and in his mind, he's thinking, all right, I know pneumonia has a cough, I know flu has a cough, the cold has a cough, you know, and asthma as well. There's probably other afflictions, but you know, just go with this for now. I'm also probably going to be wrong in some of the testing that I introduced later, but the idea should still stand. So let's take a look at this unstructured diagnostic approach. So let's say you go to a bad doctor. He hears that you have a cough. You know, in his mind, he goes, huh, that guy I just saw had a cough as well. So instead of, you know, running through his list of causes and trying to rule out things, he goes, that last person had a cold. You probably have the cold. Here's some antibiotics. And I know that may not be the exact thing that there's prescribed, but let's go with that for now. So the alternative is a good doctor might say, okay, you're having cough as a symptom. You know, do you have any chest pain? And then from the first slide, we saw that cough and chest pain were both symptoms that we were feeling. So the doctor goes and saw that the list had pneumonia. So he knows one of the ways to test is to take the stethoscope and listen for your lungs and see if they have any fluid. So he puts a stethoscope on you and notices that he hears a little bit of fluid moving. So, you know, it's kind of an identifier for pneumonia. So he ends up going on and decides he wants to do a test. And then from the test, he finds that it's a viral infection. And so a little bit of background, if you're not familiar, like pneumonia can be caused by a variety of things. There's bacterial infections and viral infections, and you handle them very differently. So in the first case, the doctor prescribed antibiotics, which is not effective on viral infections. And so this doctor actually got to the actual cause and did so using a repeatable strategy that he could share with any of his peers and get a similar result. So if we apply this to server incidents, you may get maybe a ping in the middle of the night, 3 a.m. There's a customer ticket that comes in or an error that comes up, and you read the ticket, you think about what has caused this, you start making changes to the production system and see if it fixes the problem. You know, this is not exactly what you want to do, just because you're not really taking into consideration what's going on. You're kind of going off of, you know, what may have broken in the previous times, or it's kind of haphazard. So a good response, if we go by this structured diagnostic procedure, is we read the ticket, we go through systematically, identify servers or, you know, systems that may be involved, check the metrics out to see if we can rule out issues. Like if we can figure out that, you know, there's no errors on the disk, then we know, you know, there's no hard drive problems here. We can gather all those metrics, create a list, and then from there we can diagnose what causes may lead to the symptoms that you're seeing, and then formulate a plan to approach it after that. So I have a kind of toy example that I'm going to start with, and then I'm going to have a real actual server incident that I'm going through to show you how I actually use this. But first, I'm going to talk about a specific method that I use. It's a structured method for approaching these problems. Brendan Gregg actually came up with this method. It's called the use method. So this is specifically for server problems, but I've been toying around with the idea of trying to figure out if I can create a methodology for other, like maybe developer application level problems. But this I found is like the first really good map that you can use for things like this. So his method is just basically looking at all your resources and checking out utilization, saturation, and errors. So if I have an incident, I go and I make sure that I run through my checklist all the way through checking utilization for the CPU, if there's any saturation errors, saturation or errors on the CPU, and then running through each resource. So an example that he gives is that these are the resources that you would run through on a typical, check. Looking at your CPU, you're looking at your memory, you're looking at your network interfaces, you're looking at your storage devices and controllers and internet interconnects as well. So you're kind of going through all these things and then looking for anything that looks anomalous and then formulating your plan from there. So yeah, if you want to actually use this, you figure out what servers things are happening on, try to run through the utilization, saturation, and errors on those, and then notice anything that seems abnormal, and then make your plan from there. So this is just I'll put a link for this, but this is the use Rosetta Stone, which is just his way to interpret all these errors and show you how to actually look for utilization, saturation, and errors for each of these resources. But here's my toy example. So my roommate says Overwatch is running poorly. His computer randomly shuts off. And so I decided to go and try this method out for him. And so we use CPU-Z and hardware info, and we get the CPU and GPU information. Notice that there's very high temperatures on a CPU or high temperatures on a CPU and very high temperatures on its GPU. And I noticed that the fan speeds are pretty much maxed out. So we cracked open his case, and we noticed that his graphics card was actually encrusted. It was absolutely disgusting. So the solution here is obviously just to clean that up, and then of course it started to work fine again. But my real example is something pretty close to this. So it's 1 a.m. and there's a ping that goes out, and so when this incident happens, you can see I'm blurring out names because I'm not trying to single out anyone here, but it's 1 a.m. and 15 people have been pinged for this, and then a minute later 7 other people are there. So it's 1 a.m. Nobody wants to be woken up right now, and something's not working, and nobody knows why. This is actually one of our support people, and I put this in here because he did a really good job of summarizing what's wrong, but without kind of pointing fingers at anything. So I really like that he says, we're investigating an issue with this service, talking to this service, and it seems to be happening with the CLI. And we've also seen an error in this other service, but we're not sure how they link. So he's kind of aggregating information. So he's obviously been up, he's been seeing this, and he's summarizing this information and putting it out there for anybody else. So now, of course, so the incident team got pinged, but there's actually one person that we use as our DRI, and he was our DevOps person at the point. And so he was the person who's running point on everything. And our support guy goes, "Hey, paged person, if you need help, let us know. Good luck," basically. So then people start kind of trying to figure out what's going wrong. Somebody says that there may be an issue with Frankfurt as well. And then, they came and they found that, okay, it seems to work sometimes. Static sites load, and in cloud, which is our front end, you can see that the same service is being responded to when it's coming from Newark, but not from Frankfurt. So it's not really easy to kind of figure out what's going on here. And so he's still trying to get his bearings and trying to figure out what's going on. And so actually this last comment here is the first kind of indicator of understanding the system. And this individual had been on the team, or he's been at Linode for a long time. So he kind of has an understanding of where data flow is and things like that. So he kind of hits it on the nail before we get anything, but he says sporadic inaccessibility would point to either an issue with the BAPI box or a single Oz proxy box. So the way this is lined up, we kind of have customer requests coming in from the internet, and if they want to create an object storage key, for example, it would go through and hit our backend API, which is what BAPI is. And then the backend API talks to the OS proxy box. But the details of that aren't really that important. The the idea here is that he's seeing the data flow and saying that it seems to be like the issue would exist within the backend API servers, which is true. So, it's 1:30 in the morning, and the Slack channel, everybody's throwing their ideas about what could possibly be going wrong, and I get after reading through it, you see somebody says OpenSSL was updated recently. Someone says OpenResty isn't listening on port 443. Somebody throws that TLS might be broken. Cloudflare, which Cloudflare is not even involved in this system. OpenResty might be under the wrong user, and then I think there was a literal shrug emoji at one point. So the solution strat, we're restarting basically all of the services in the line from the customer to the database. And so now it's 2:30 in the morning and the problem's still there. So then, the guy who's kind of running point goes, hey, there's no run book for like what I do at this point. And it's true, but like there's kind of a run book that shows like how to restart the service and stuff like that, but nothing that says, if I'm seeing intermittent issues between two services, what do I do? So at 7 o'clock, one of our senior developers, Will Smith, and that's his real name, joins the fray. And he does something that I think is a systematic method of his own that he's developed. And he's kind of known at Linode for doing really good work and just like being able to find root causes of things very fast. And so his approach is exactly a systematic approach, in my opinion. He's coming from all of our error reporting services. So he's looking at Sentry, he's looking at New Relic, he's looking at Grafana, he's looking at Kibana, and he's kind of aggregating this information. So he sees on Sentry that the backend API has started to show an uptick in errors. So he goes and takes a look at those errors, and then he starts testing on his own personal laptop. And one thing I really like that he did here is he not only does the testing, but he's clearly communicating what's going on, like what he tests, what works, what doesn't. And then the last bit is kind of just a little bit of one of my friends at Linode here. He joins just because he knows something's broken, and we have a very good culture of when things break, everybody gets very interested. So he just joined because he knew that something was broken, but wasn't actually helping. So Will keeps going and tests some more things, and he notices the problems are isolated to certain boxes, and even the fact that like we're timing out at very specific times, 4 minutes, 40 seconds, and some change. And he kind of figures out that this is related to hitting all of the proxies and then returning back with timeouts. So at this point, I'm so new to this product that I'm not even in the like Slack handle for the group, along with one of my coworkers who's also at the conference. So Will brings us in, and at this point it's 9 o'clock, still no resolution. The networking team comes in and they say, doesn't seem to be a problem with networking. I can hit, servers fine. And then I'm still kind of waking up, not really using any specific method yet. And I'm, looking to see if I can get any more logs or any information. So after, I asked for the logs, I started to actually try and rule things out. So according to our networking guys, it says we seem to think routing's fine. And then, the failure seems to be between these two services, BAPI and the object storage service. So then I decide I'm going to actually go through and do this method. So I hopped on our BAPI boxes that were causing problems, and I ran through each of the resources in using my method. And then when I got to the networking interfaces, I took a look at the outgoing connections that they had toward the object storage servers. And then I noticed that, there's a lot of connections in send-sent. And so I'm not like super familiar with TCP. So all I did was I went to Wikipedia and looked it up. But Will was also trying to solve the problem at this time, and he noticed that he's doing an apt-get update, and then we're failing to even talk to security@debian.org. But there's ping connectivity, randomly. So it's at this point, it seems to him that like we have networking issues, but we don't know why. And then I noticed that there's actually let's talk about the TCP problem. So what does SYN sent mean? So if you take a look at this diagram, SYN sent means that as a client, I have sent a SYN packet and I have not received the ACK back from the server. So I haven't established my connection yet. So that means that all of those connections that we're seeing here in SYN sent are actually trying to be routed to the servers, but they can't actually reach it. And so we'll talk about why that is a little bit. So at this point, I'm just posting the information that I see that's anomalous in our chat, just trying and see if anybody else can make sense of anything that I'm seeing. So once I saw that, I started asking questions, and I'm like, so it looks like the IPv4's connections are succeeding, but the TCP6 ones are waiting for a response. And then, we started to kind of go down the track there, I think a little bit early, where we were saying, all right, let's try to force the box to use IPv4 instead of 6. But then, I finally asked the question, like, why are there these two separate v6 addresses on this interface? And then the networking guys start to look at that, and they notice it, and they say, yeah, that's definitely suspicious. And then we found out that if you can see, there's a 2A01 and a 2600 prefix for the IPv6 addresses. The 2600 one is actually in Dallas, which is where this box lives, but the 2A01 is actually an IP from London. So that packet, when it hits our routers, can actually be routed. And so the issue is that, when our application was trying to bind to this interface and use the IP to route a packet, it was actually binding to an address that couldn't be routed back to. So we actually solved this problem just by, going through this method and then finding things that don't look within the norm. So that was just solving the problem of whether or not or where the issue actually lied. But so we solved the problem of why this box could not talk to our object storage. It was another problem to figure out why this IP had been added to this interface, but that's a story for another day. So yeah, we eventually ended up just like deleting the extra address as a temporary fix so that we could get customers back online. And then that was it. So we solved our problem, and we were doing the method. And actually, this incident happened again a couple weeks later, and I wasn't even involved in diagnosing it. So I showed my team what I did to find it, and then they were able to replicate the steps and actually diagnose it for themselves. So I freed up my own time for that. So I think this is something that you can use to give to your teams as a way to kind of intelligently talk about how you've solved a problem in the past and be able to approach new problems that you may not yet have seen in the future. So yeah, that's my talk. So thank you. And if you have any questions, let me know. I'll be sticking around in the chat for when we switch to the other talks as well.
Yes, thank you so much, Adam. Adam Mohammed from Linode. So we next up, in a couple of minutes, we will be hearing about modernizing ancient protocols. That is from Ricardo Cygnus from Fastmail. So that's coming up at 1:35. Are you starting right now? Let's see. Start in a couple minutes, I'll say that. So Ricardo's going to jump up, and he's going to give his case study in a couple minutes. Again, we're talking about modernizing. Oops.